of a hassle then, because I'm on my laptop and I always need to switch the screens here to accept people for the Google Meetup. So excuse that I sometimes probably need to switch back and forth from my presentation, but I hope you can handle that. All right, that said, I will give a short intro and then we will have Vlad talking. So let me share my screen. Can you see it? Yes, right? Good. All right, yeah, so welcome to the Data Science Meetup Hamburg, which is historically Hamburg, but nowadays often online as of now. So there are people from many places, but still this is how this meetup came about. My name is Mark, I'm the host of this meetup, and this is the little overview for today. I have some small announcements, and then I will introduce you a little bit about this meetup group. And then we will have Vlad, who's a data scientist at Quantum, talk about automated testing of web applications with an intelligent agent. So I think that will be quite a cool talk. Let's see what he has to say about it later. All right, now for the announcements. You probably have seen it already. So there are free open passes to the AI Dev World, which happens end of October in San Jose, or November 1st to November 3rd virtually. I created an event for it where you can get your free ticket if you like. It's just a meetup event, so don't confuse it. There's nothing happening in that event actually. It's just that you have the awareness that you are able to get these free passes if you want to. Then I have a fun project that I created. It's called This Shirt Exists, where you can generate your own t-shirt designs with AI. So basically you enter text and the AI turns it into images. So I have a small video here that shows it. So here you enter some text like a cat surfing a wave. And then with Stable Diffusion, images are either retrieved or generated. And then you can just add them to your t-shirt and print and get the t-shirt if you like. So check it out, thisshirtexists.com. It's playing, okay. And then I have another fun hack currently going on my Twitter page. So I play a lot with Stable Diffusion right now. I think it's quite cool. If you reply to any of my tweets, then your text will be turned into an image and added to my Twitter banner. That's why it looks so destroyed now. And would be fun to see a few of you trying it out if you like. So just go to twitter.com/mpepper. You can reply to any of my tweets with some text, and it will pop up in my banner in around 20 seconds or so with the bot. All right. There's someone coming. Oops. So a little bit about this meetup group. It's Hamburg's biggest data event with more than 3,000 people. And since last month, we have 90 new members to the group. So there are more and more people joining, which is awesome. And not only it's the biggest, also the most frequent data event in Hamburg. We usually have 10 events per year. That is one per month with a summer and winter break. So I always try to find cool speakers and have a lot of data talks here. Someone else joining. And what's really important to me is diversity. So I want to have everyone the chance, to give everyone the chance to participate in this meetup, to speak, to show their work. And it doesn't matter if you're a beginner or an expert, male, female, other, whatever, just come up with some idea and hit me up and we can talk about you giving a speech here. And from the topic, so it's also very diverse. We feature everything from research to production stuff, hands-on hacks, whatever you like. The only requirement is that it somehow related to data, machine learning. And this is also a very good opportunity for you because if you do that, you present here, you gain valuable speaker experience, maybe to present at some conference. You also can get feedback on the things you've been working on, get into nice discussions with colleagues. So yeah, I think it's a really fun opportunity always. And the next meetup would be in November, but currently I don't have a speaker yet, so the urgency is real. Please contact me. You can write me an email, for example, at mark@pepper.com, or write me on my Twitter page, whatever you prefer, or just talk to me here in this meetup afterwards. That's already it from my side. Are there any questions right now from you? Okay, then I will pass it on to Vlad.
Okay, thank you, Mark. Okay, do you see my screen? Yeah.
Yes.
Okay, great. My name is Vlad Khramtsov. I'm a data scientist in Quantum, and my talk will be dedicated to automated testing of web applications with an intelligent agent. And a few words about me. I'm a data scientist, and I'm passionate about different ecological projects. So my first very large project was dedicated to deforestation detection, and currently I'm working on analysis of different drone and satellite images for simply tree analysis. And also I'm a part of our research and development team in Quantum. In this team, we develop different interesting things, test some hypotheses, like autonomous greenhouse for salad growing, like carbon dioxide measurements for large-scale forests. And this project is also part of our research and development. And we publish different papers, publish licenses, we create different Python libraries and so on. And also I'm a PhD student in astronomy, so yeah, research is my love. And about the talk. So today we will describe the concept of an imitation learning. Then I will describe you our tool called SAM, which we created for the web data collection. Then I will describe you our solutions, and we will talk about results. Our team was quite small but very strong, so it consisted of our CTO of Quantum, Alex, which was our client and the project manager at the same time. Also, we had the Michael, team lead of our data science department, which is a very great online generator of super ideas, me, and Fatima, our hero QA engineer. So let me introduce the project from the very abstract concept called digital device control. So the digital device control is an automated process control on any digital device, and currently this is a very hot topic in the ML. And for example, with the model for digital device control, we can automatically fill up and scrap some information within any application. It may be useful in the case of, for example, large data set of some handwritten information like medical notes, some documents, and we want to scrap this information and fill up some forms on the website or in the application automatically. Also, such models can be useful in digital assistants on mobiles, in computers, and so on. So this is a very cool concept, and we decided to dive into this topic. And we started with the very general but close to us problem, namely the web application testing. So during the testing of web applications, we want to infer some, simply speaking, bugs in the web application. This is very useful for any application. And currently, there are only two methods exist. The first one is called manual testing. With this kind of testing, we have some QA engineer which simply hand operates the website, the web page, web application, with the main aim to find bugs. But this approach is time-consuming, this is not reliable at all, and we cannot fully reproduce all manual tests. Plus, it is at least inhumane to run manual testing after each commit. So also, we have a second type of testing, which is called automatic testing, but this is so-called automatic because actually we need to write some scripts. Some scripts which operate with their web application and act some predefined actions. And it is obvious that this type of testing is highly sensitive to the source code. So when we have some changes in the source code, we also need to change the code base. So actually this process of automatic testing, scripting approach is not fully automatic. And we want to create some model which can test web applications fully automatically or with a minimal human invasion. Also, this is useful from the point of view of resources. These two approaches make an overhead from experience of our projects. They add about 30-50% of resources for development. So it would be very cool to develop an automatic solution. And from the data science point of view, this problem, this task of automated web application testing may be solved in many, many different ways. But we picked up the most without promising and the easiest one, which is called an imitation learning or behavioral cloning. So with this approach, you simply should train some model, for example, with supervised learning, simply to imitate the human behavior from some recorded demonstrations. The vivid example of imitation learning was presented a few years ago by NVIDIA. So that was a very, very first practical example of an imitation learning, where researchers simply recorded a lot of videos from the camera on the car, frontal camera on the car, which observed the frontal road, and also they recorded a lot of actions of drivers. Then they simply trained the neural network to repeat the driver's actions from the video. Yeah, and the model that was trained in such a way was able to drive around 10 miles without any human invasion, just with the imitation learning, just with the learning from demonstrations.
Quick question
Yep.
on drive on the on street that it trained on or new pathways.
I do not remember exactly.
Okay.
As far as I remember, the environment was quite easy for the model. So that was a road, not in the forest, not in the city. So simply a road and some crops around. I can share the link to the paper after the meeting. So yeah.
Cool, thanks.
Now, yeah. And we saw that this approach can help us in our problem. So we also recorded a lot of demonstrations. But for our particular problem of web applications testing, we have a few requirements which are very severe. So first one is that we want to have the end-to-end behavior of our model, which imitates the human. So all steps of each test must be done correctly. All tests of model must repeat all actions without any mistake. If model clicks in any place, in another button, for example, we will simply go through the not desired path. Yeah? So we will test not things which we would like to test actually. Also, due to this point, we also have no any cross-validation. So we have no any training, testing, validation, data splits. We have a single large data set of recordings. And this data set is our training test and at the same time the test set. So in the case of any new scenario, our model will be not knowing what to do because it didn't see any demonstrations before. And also we assume the recurrent process. So the model can decide what to do only from the current state without any historical previous information. So actually it observes the state and decides what to do right now. As the input-output information, we used the screenshots from the website as the input information and required from the model to predict the coordinates of the click and the input text, which should be inputted into the fields. So with this problem, we should collect a lot of data, and we didn't found any platform, any product which may help us to collect such a data set. So we created our own tool. I might say this is a very cool tool. It is called SAM. And here I'm showing you a demo of it. So with the SAM, the key engineer should enter the link to the web page. Then engineer enters the name of the test, for example, login successful, and starts recording. With this, engineer somehow acts with the website. For example, here engineer enters text some password into second text field, and the SAM for each action stores the entire screenshot of the web page. Also, it stores the coordinates of the click, and also it stores the input text. So we do not always have the input text. For example, for the next action, we have only click coordinates pressing the button, login. And during the recording, we may pause it, we may abort it, and at the end, we can finish it with one of the labels, success or failure. Also, with the SAM, it is possible to rewatch all recorded tests, and SAM can upload the model and predict the coordinates and actions for the current state with the model. So yeah, with this SAM, we collected about 300 different tests. For each test, we conducted some actions, and in total we collected about 4.5 thousand different actions. Each action is simply the recorded information from SAM, that is the screenshot and image, click coordinates, and the text. So yeah, here you can see the demo of it, of some tests. And yeah, we have an image, and we want to predict the coordinates of the click, and we want to predict the action which should be done for the current state. Thus, we decided to use convolutional neural networks. And we used CNNs in the following way. So our CNN, our model, inputs two inputs. Yeah, the first one is the screenshot, an image which was passed through the ResNet model, and the name of the test, simply text, which was vectorized. Then two vectors were concatenated and passed through the fully connected layers with two outputs. The first one for the actions, and the second one for the coordinates xy. So yeah, all seems intuitively correct. So we have a screenshot as the input. We don't know which test should be done. A model simply should predict where we have to click and what we have done during this click. For example, enter some text. And the model was quite successful in predicting the actions. So around 97% of actions were classified correctly. But the model had problems with regression of coordinates.
Is this now on test set results?
This is results on our set of demonstrations. So as I said, we recorded around 300 tests. Let me say scenarios, yeah. So each test is actually a scenario, to be not confused with the train test in the machine learning. 300 scenarios, and all these scenarios were used to train the model. And then the model was running on all these 300 scenarios. So model should simply overfit, I can say, and repeat all the actions, just to repeat all the text. So with such overfitted model, we able simply to run this model, after each commit to test the website. But we had problems with coordinate regression. And my question to you guys: why? What do you say? So what is wrong in this approach, maybe? On the right, I have a small hint. So here is the green circle is the click of demonstrator, and the red click is the click of the model.
I don't know if you can see it, but someone has raised their hand.
Yeah.
Do you see that as well? Okay. I think just speak up if you have an idea or so.
Yes, it's because of the resizing of the images. So the model is trained on the resized image, but it could also be because of the different convolution layers that the convolution itself resizes, but normally the attention map is always pointing to the resized image space. So then the image itself has to also be resized.
Yeah, I would also think padding in the CNN operations maybe. Something like that.
Yeah, so you just described effects which affect the output, but the result is that we simply cannot hit the UI element. So the model cannot actually see, now for example here the cross icon, but due to resizing, due to padding, due to very rough convolutions, the model actually cannot hit exactly that pixel which corresponds to the center of cross, for example, the center of button. Yeah, so the model does not know anything about the UI elements. It's just trying to hit somewhere nearby to the target place. So from the model's point of view, this error might be quite small. This is much smaller than 90 pixels. Yeah. But for us, this is a crucial error because in this case, we will hit not in the buy more button. We will hit in the button copy link to share, which is actually different button, and we would not know to hit in it. And we tested the accuracy of hitting different UI elements and observed that the model was able to hit about 35% of icons, and icons are this like cross, T, star, bell, and so on. So these very small elements. About 75% of buttons like this by more, and about 90% of text fields. And this result is intuitively logical because icons are very small, and due to different CNN effects, as you said, model cannot hit exactly at these elements. But buttons are quite larger, so they are also in a contrast with the background usually. So model hits these elements with 75% accuracy. And the text fields are very wide. They are very large elements, and this is very hard to miss such text fields. So we decided to help our model with understanding what UI elements are. And we did this with approach which is called CharGrid. So basically CharGrid is a model which was presented a few years ago for optical character recognition of invoices and different scanned documents. And the idea of this approach is very, very simple. So we have an image with the text as in, and we want to predict the segmentation masks of different characters. And our problem may be reformulated to this problem because any button, any header of the text field, any icon, this is simply a symbol. So we can create some segmentation model which segments the symbols. And as the training data, we used our static data set of about 100,000 images, very small images, which contain different alphabetic, numerical characters, plus we used 41 UI elements. And each alphabetical and each numerical character had its own class, while the UI elements were merged into the single class. So we trained the model on such a data set and obtained quite a good accuracy of segmentation. The symbols about 99%, but the model was very large because we need to output about 38 channels, segmentation channels. So model was large, and the speed of it was very low, about 5 frames per second. And we use this CharGrid model to help our domain QA model to understand the UI elements. And we did this in two ways. So first of all, we simply put the outputs of CharGrid as an additional input to the main QA model. And also we found all symbols on our screenshots, all characters, all icons, simply remove them to keep, UI-like information on the image, like buttons, text fields, other blocks, pictures, and so on. And the rest almost is the same, except that we used the custom CNN because ResNet is too large model for such task. And the custom CNN was a lightweight model simply to reduce the memory usage. And the rest is the same. So as the output, we have an action classifier and regression of coordinates. And we observed quite a good increasing of the scores. So classification accuracy was about 99.9%, which is very, very good. And the regression of coordinates was about 26 pixels. And again, my question to you guys. So we had about 300 scenarios. And what do you think, which number of tests such a model passed successfully from end to end? About 5, 10, 100, 300.
25.
How much?
25.
25. Close enough. Actually, 5. 300. So yeah, we revealed a few issues. And the most severe issues was overfitting. Yeah. This issue occurred because we had a lot of states screenshots which were repeated across different tests. For example, the login page for each test, we should log in into an account to conduct different actions. And the model saw login page very often. So probably model was overfitted in such examples and wasn't able to predict the correct actions on these overfitted examples. And still, model had low UI detection quality. It had very low performance due to the error grid about 1 frame per second, and the success rate was 5 tests. So we decided to move to another class of models, and we call this approach external memory. So with this approach, we simply have some external memory. This external memory stores some cutouts around the clicks and corresponding actions. So this is some set of templates. And with this approach, we want on the current for the current test on the current step, take the corresponding template, locate it on the screenshot, and act some action which start with this template, with this small screenshot. Yeah. So this method is summarized here on the left. We have a set of templates which we can create easily from our recordings. Also, we should have some matcher, the model which matches the template on the screenshot and locates the correct position. And an executor, some model algorithm which executes the action. And we don't have any problems with templates and executor because templates, as I said, we can create easily. Executor simply executes the action which is stored in templates. But we have problems with the matcher. And the matcher is simply some pattern matching model because we should find the similar sub-image on the whole image. But also we have a few requirements to this matcher due to the nature of our problem of application testing. So first of all, our matcher should distinguish similar design elements. This is very important because the web page, each web page usually contains a lot of very similar elements and so on. And the matcher should differentiate between them. Also, the matcher should be robust to changes in appearance, like changes in color scheme, changes in fonts, font sizes, and so on. And also, it should be robust to small shifts of UI elements. By the way, below you can see the examples of templates from the external memory. The click is on the bottom right. So we want to simply take one of these template, locate it on the screenshot, and act some action which should start with this template. To train the model, we use simply synthetic data set. So basically, our matcher should output some similarity score for 2 input images. So it is very easy to create a training data set for such a task. And we did it in 2 ways. First of all, we generated fake screenshots which contain the text only, like on the left. Here you can see a pair of template and some query images. Here you can see some fake buttons like continue and login, and the class false. Also, we created additional templates and the query images from the real web pages, not our target one, which was used to record the tests. So we simply took a lot of different screenshots of web pages, simulated clicks, simulated the templates, and created the pairs, queries of different classes, positives and negatives, to these templates. Also, we revealed a cool trick which can be done with the class activation maps from the previous CNN model, which was not successful, but it was useful in this stage. So we can use class activation maps to locate, I might say, useful information on the cutout. For example, here you can see some tile, some cutout, in which we see some button BBBM Unity, learning subjects, my tools, and manage courses. And with class activation maps, we can automatically, without any training, supervision, create segments of these useful elements and mask everything which is outside these elements. So we start designing our matcher with simple CNN, which accepts 2 stacked images, and the accuracy of this approach was not very good, about 56% of matching accuracy. Then we've done the hard negatives mining. This adds about 4%. Then we experimented with the architecture and choose the CMS architecture. So basically this is simply a network with 2 input branches, 1 per each image. And we had the shared weights. So this architecture increased the matching score up to 74%. And also we added a few tricks. First one is the temperature scaling loss. This is simply a calibration of neural network output. And also we used the special transformer network, which was trained together with the CMS architecture to learn some translation of the query images relatively to the templates, to find the best matching and to prevent low matching scores for slightly shifted images. And we use special pyramid pooling layer, which is simply a set of different poolings, but with different scales. And in the result, we obtained about 95% of matching accuracy.
So the SPP is for having detecting the elements of different sizes, the icons and stuff?
Sorry, yeah. So SPP was very useful in multi-scale learning because the entire tile may contain useful information. Like here in an example, this is a small picture of the DiCaprio, which is cut down, and some girl. And this is quite a small field. The model should be able to train in that small area. So yeah, SPP was quite useful in this problem. But we observed few issues, very bad issues. The first one was connected to very similar elements. Here you can see 2 examples. So model simply confused 2 text fields, which are called password and username. And these text fields are quite important for our test. So even the number of letters in these 2 headers is the same. The model simply wasn't able to differentiate between them. And the second example is 2 buttons, access and people, and each button had an icon nearby. These icons contained icons of person. So model was not able to differentiate between these similar elements. And also we observed that actually we, not often, but we had the same UI patterns on the single web page. Here's an example. This is an example of 2 cutouts from the single web page. And these images are not similar, they're identical. So matcher simply doesn't know which one it should pick up. But with this, we were able to match approximately 95% of templates. Here you can see the demo of how the model repeats the tests on the real website. So in the result, we were successful in performing 220 scenarios without any human invasion. And here the summary. So during this project, we created GSM, our tool for web data gathering. Then we tried the CNN model to classify the actions and regress coordinates from screenshots. Then we tried to improve the CNN model with the grid model, which is an optical character recognition system. It's not helped to the CNN model, so we switched to another class of models, namely external memory, and trained some neural network simply to match templates on the screenshots and got the best results. And a few words about our current state of the project. So a few months ago, DeepMind released the state of the art in this field. They trained the agent on the mini word of bits ++ environment, which is simply environment of different web pages, which are very minimalistic, very simplistic. So yeah, they trained an agent to conduct some actions on this website. And here you can see differences between our approach and their approach. So first of all, we collected about 4,400 demonstrations, while DeepMind collected about 2.4 million demonstrations. And the duration is also different in highly, so we collected about 15 hours, while DeepMind collected 3,000 hours. We had one demonstrator, and DeepMind had 7 demonstrators. And at the same time, we considered about 300 scenarios, different tests, while DeepMind considered about 100 very simple, relatively to our environment, scenarios. Yeah. And the success rate, so we had about 70% of the success rate of passing these scenarios, and DeepMind had the state of the art about the human level performance. And analyzing this paper, we can make some conclusions because this paper from DeepMind is actually a recipe of how to do the model for automatic web application testing. So first of all, we should have a lot of demonstrations in order of 1 million demonstrations. Also, we should use document object model. This is simply a code of any web page, but we assume that the screenshot contains all required information to fulfill the task. And also, DeepMind revealed that it is not it is mandatory to train the imitation learning model together with the reinforcement learning model. So currently, our research is focused on usage of this document object model because computer vision methods are not efficient enough for our task. And we switched to simpler problems, like not conducting the full test of n steps, 20, 30, but we require to follow some simple one-step instructions from our model. And that's it. I'll be happy to hear your questions, and in the case, you can write me on email and visit our website. That's it.
Awesome. Thank you very much, Vlad.
Thanks.
Very good. very good presentation. Really cool idea, I think, and also really like how you presented, how you iterated on improving the model. Very cool.
Thanks.
Yeah, so are there any questions from you guys? Akbar, yes, go ahead.
Hi. My name is Akbar. I think you already saw. My question is, was there any animated scenario, like was there any page which is animated, some buttons are moving, or any interaction? The scene changes depends on the interactions, like hovering or whatnot, or was all static pages like this login pages?
Yeah, we experimented with the static pages only, without any appearance changes or shifting of elements. So we required from the model to fulfill these tasks at least. Yeah. So with the success with these tasks, we would move forward to more complex tasks. But currently observe that we can fulfill only 70%, which is not enough to run the model on the more complex
pages. Okay, I see. I mean, the animations are pretty standard nowadays, so there will be some animations and changes in the page. I just wonder if it's gonna confuse the algorithm or not. One more thing, when you do some actions, page changes, and how do you detect the page change? Because it can take arbitrary time, depends on delays, whatnot. So how do you detect when the page changes and what will happen next?
Yeah, this is a very good question. So actually, we observed that we do not have any repeated states. So we had some misclicks by our QA engineer, which were removed. But actually, all states for a given test are unique. So the model even should not input even the step. Yeah, so it is fully time independent. Like here, we put some login in the login field, and the screenshot is different. So we have some text. When we press some button, some changes on the side we can see. Yes, so the model also observes these changes.
Okay, yeah, exactly. Selecting the user, and but my question is how it detects. Like when you click the avatar, it opens the menu, and then you continue with selecting the profile there. How the detection happens? Like, is it just waiting certain time, or is there another decision behind it?
Are you talking about the SAM? How SAM collects the data?
Yeah.
Or...
No. I mean,
no?
Right now in this example, for example, Sam clicks the profile link.
Yeah.
And then menu opens, and then it clicks the profile, and it goes to another page. So between that clicking the Leonard avatar image and then selecting the profile, like that detection, is it just a delay for a certain time, 1 second, 10 seconds, or is there any other detection when to do the next action?
No, this is just delay, and often this was delay, human level delay, because we run this model with the SAM.
Okay.
And there was a button predict, so we hit the button predict and waited until our model predicted some coordinates and actions and exit. So yeah.
Okay. Yeah.
So when you click predict, then basically you make a screenshot and send it to the model, and then it gets you the action. Okay.
Yeah.
Okay. Thanks.
Thanks.
I also have a question. So you mentioned that maybe vision is too weak and you want to go further in the document object model. But isn't that then more coupled again to what you said in the beginning, that you have it bound to some, IDs on the page or something like that, and when you change something, you need to programmatically change something again? Or maybe I didn't understand it fully.
So sorry, I can catch your question. I apologize.
So
can you repeat this?
Yeah. So I mean, you said instead of focusing on vision, you want to focus on the DOM, right? My question is, but if you use the DOM, aren't you just using IDs or things like that again of elements, and then it's kind of coded in code again, and what you said in the beginning, then if you change something, you will have that trouble again?
I can say about the DOM because currently I'm not working with the DOM, with this project.
Okay.
Our team is dedicated to continue this project. But as I understand, the DOM consists of some, not exactly IDs, but some text. Yeah, so we can see in the DOM that okay, this is button login. Okay, this is the text field password.
So you mean you send just the source code to the model instead of the image, basically. Yeah. Okay, that makes sense.
And you can use some language models, for example.
Right. Okay, then I misunderstood that. That makes sense. So this is an internal research project currently, or is this for some customer also?
Currently, this is internal project, but we used the SAM and Chagrit and customers projects.
Yeah, to reduce the internal QA effort, so to say.
Yeah.
Oh, really cool. Nice. Do you think this might become a product at some point?
I believe. I believe yes, because this is very good idea of automating the process of web testing, and it may be generalized to much more general problems. Yeah, not only web applications testing, but many other problems. And this product will be useful for many people. But currently this is research and development. But I believe we will push it into the product.
And how long did you work on this?
This project was done in 3 months.
Nice.
Including the labeling by Fatima QA engineer and our development of the data science part.
Very cool. And how did you do the iterations? So, I mean, you showed the slide where you used negative mining and stuff like that. How did you come up with the different ways to iterate or improve the model? Yeah, this one.
This was simply manual grid search of different ideas. So we stuck on this 74% because it was quite easy to go through this path. So we understood that simple CNN is not working. Hard negative mining is good, but not enough. We tried the most intuitive improvement is CMS architecture. But after that, that was very hard manual grid search over different approaches, papers, and so on to improve the score. So yeah, we tried a lot of different methods, approaches for our problem, and found that these three ones, temperature scaling loss, special transformer network, and special pyramid pooling are the best for our task.
Okay, cool. I asked a lot of questions. Maybe someone else has some questions because I have more. No one has any more questions? Okay, then I'll keep on asking.
Okay.
So I was wondering, what do you think about adding text-like scenarios into this? So I was thinking maybe, describing tests as kind of user stories, in text, and then using, all these fancy GPT-3 and whatnot for text understanding and building that into that. Have you played at all with that or ideas like that?
Yeah, we are currently working on the idea of using the so-called instructions. So we put to the model simple instruction like put login into login field, and model should follow this single instruction. So yeah, this is large decreasing of the complexity, because the test may be very long. It may have 50 steps, but a single instruction, single natural language instruction, which is put into the model, is, I believe it will be much easier. Yeah.
Awesome. I'm really looking forward to hearing more about this. Hopefully it will be a cool product. Okay, anybody else got any questions? Doesn't seem to be the case. In that case, Vlad, Marcus has a question maybe?
Yes, I have one question about the visual model of the CNN, the unit structure you have used. Is this actually the state of the art to use char grid for these web applications? Or did you consider other visual transformer models also? Just as a question.
Yeah, we did not consider visual transform. First of all, we had not enough data to train, I think, successful vision transformer model, and the simple convolutional neural networks were failed with this task. So instead of improving the CNN architecture, we decided to move to the template matching problem, because we understood that this improvement might take too long time. Probably, yeah, vision transformers may help, but we didn't check this. We tried the CNN, we experimented with this CNN model, then we tried the chair grid, experimented with this architecture, and then decided to move on.
Question about data acquisition. So how to, if you would have an idea how you can select more data, for instance, from much more users, would you also think about I don't know if this would be a task you can just ask as a request to limit type or something. But something like this, you have a much larger amount of brain data for this, or could it be that because of the few web pages you display, the variance is so low because there's just simply the mouse is just the only thing which moves, and the only thing which changes so much that it doesn't make any sense.
Yeah, so the data data is a huge problem in this task. DeepMind showed that we need at least 2 million different demonstrations to train quite successful model. We tried an approach of simulating the web pages, simple web pages with an HTML, and simulated the actions with the Selenium. But the Selenium environment is not precise enough in terms of coordinates of the click. So, but we wanted the real world data, human-like, with the good accuracy. So we should use tools like SAM. And we did not even try to share. Now, for example, we can collect more data like it was done in the DeepMind. So they simply created a task in the internet, paid to the people to make some actions in their environment. We didn't think about this, but probably this is a solution, because more data is a key, I think, in this task.
Nice. Yeah, obviously.
Yeah.
Cool. Any more questions? Now's your last chance. Doesn't seem to be the case. Okay, then Vlad, thank you again for the awesome presentation.